Alright, so let us get started with MIT Integration B qualifying exam. And this is of year 2023. So let's get started. These are the set of questions that we are gonna solving. So question number one, yeah. So starting with question number one. So the first question says to evaluate the integral of x 1 over of ln x dot dx. Alright, so this could be written as x ln log of e base x dot dx, and as we know that a to the power of log of b base a could be written as b, so this could be written as integration e dx, so the answer is ex plus c. Next question, integration of highest sec hyperbolic x dot dx, so this could be written as integral of, okay, as we know that 1 by cos hyperbolic is equivalent to secant hyperbolic. Right, x. So this could be written as 1 over of e to the power of x plus of e to the power of minus x by 2 dot dx. So this could be, okay, written as 2 e to the power of x by e to the power of 2x plus 1 dot dx. So e to the power x could be taken as t. So from here we can do 2 by t square plus of 1 dot dt. So 2 tan inverse of e to the power of x plus of c. And here's the answer. Okay. Or in other words, if you say it as arctan, then this is 2 arctan e to the power of x plus of c. Okay. Although the answer key does not says about c, but we will write it. Okay. Now, next is integral of e to the power of x by e to the power of x plus of 1 ln of e to the power of x plus 1 dot dx. So I'll take this as t. So if I'll take this as t, this will become e to the power of x plus 1 dt, t by the derivative is 1 by e to the power of x e to the power of x. This got cancelled, so we are left with ln of ln t, which is equivalent to ln 1 plus of e to the power of x plus of c. And yeah, here's the answer. Question number 4. 1 plus of 1 plus of x square plus of x cube plus of x to the power of 4, 1 minus of x plus of x square minus of x cube plus of x square dot dx. Okay, if I'll observe this carefully, then this is actually a geometric sequence or GP. Okay, this is a GP. And for if a GP is written as a plus AR plus of AR square plus of AR cube plus up to AR n minus of 1 with n terms, then the summation up till n terms could be written as the first term times 1 minus of the common ratio, that is r whole to the power of the number of terms divided by 1 minus of common ratio. So using this formula we can write it as 1 multiplied by 1 minus of x to the power of 5 by 1 plus of x and times of integral of 1 minus of x 1 plus of x to the power of 5 dot dx. And this could be written as 1 integral 1 minus of x to the power of 10 by 1 minus of x square dot dx. Okay, and from here we can write it as 1 minus of x square. I am doing some kind of manipulation. Okay, so 1 minus of x square dot dx. So yeah, I okay, yeah, so I could be written as 1, okay, plus of x square into, this one is x to the power of 10. Okay, yeah, 1 minus of x to the power of 8 by 1 minus of x square dot dx. So yeah, okay, from here I could be written as 1 plus of x square into 1 plus of x to the power of 4 into 1 plus of x square into 1 minus of x square by 1 minus of x square dot dx. So 1 plus of x square into 1 plus of x square plus of x to the power of 4 plus of x to the power of 6 dot dx. So 1 plus of x to the power of 2 plus of x to the power of 4 plus of x to the power of 6 plus of x to the power of 8 dot dx, right? So from here we can write I is equal to x plus, I'm evaluating the integral, which is x to the power of 5 by 5 plus of x to the power of 7 by 7 plus of x to the power of 9 by 9 plus of c. And yeah, here's our final answer to this integral. Okay, next question. Next question is to evaluate 0 to 4 and in the combinatorial form x over 5 dot dx. Okay, this is written as xc5, integral of xc5 dot dx from 0 to 4. So using the combinatorial techniques, I can write it as x factorial by x minus of 5 factorial by 5 factorial integral with respect to dx. So this could be written as x multiplied by x minus of 1 into x minus of 3 into x minus of 2 into x minus of 4 into x minus of 5 factorial divided by oh yeah, okay, so from the so the limits are from 0 to 4, from 0 to 4 by x minus of 5 factorial 5 factorial dot dx. So this got cancelled, so we are left with from 0 to 4 1 by 120, because 5 factorial is actually 120. So from here x multiplied by x minus of 1 into x minus of 2 into x minus of 3 into x minus of 4. Now the cleverness in this question is that this function is actually very much symmetric to x-axis. Okay, how? Let us see it. So basically, the function is like 1, 2, 3, 4, or else again. The function is like something this 1, 2, 3, 4, 5, like this. Okay, that is 1, 2, 3, 4, and the limit is running from 0 to 4. So this is the area A. This is the area B, this is the area C, and this is the area D. And since this area, if this is plus A, then this would be minus of A, B, minus of B. So the net area is actually 0. So the answer is 0 to this question. Okay, next. Next is to evaluate question number 6, that is x plus of sine x plus of x cosine x plus of sine x cos x dot dx. Okay, all right, so in this question, what I'll do is that I'll take it as x plus of sine x dot dx. Okay, plus of, I'll apply uv method. U taking this as u, taking this as v, and if you have forgotten it, I'm writing it down again. That integration of uv dx, that is look, I'm doing nothing else, but I'm doing integration by parts. So this could be written as integral of u, integral of v, okay, or else u integral of v dx minus of integral of du by dx integral v dv v dx whole dx. This is integration by parts, or else sometime people write often it as uv prime minus of uv minus of integration of u prime v. Anything that you will write there, it's your choice. Okay, so yeah, this could be written as x sine x minus of sine x dot dx plus of integral of sine 2x half sine 2x dot dx. So from here this could be written as, okay, from here sine x got cancelled, so we are left with x square by 2. I am evaluating the integral, so x square by 2 plus of x sine x, okay, minus yeah, so minus of 1 by 4 cosine 2x dot dx, right? So x square plus of 2 sine x multiplied by x, okay, minus of 1 by 4, minus of 1 by 4 into 2, uh, yeah, so 2, 1 minus of 2 sine square x dot dx. So x square plus of 2 sine x, actually in the answer key it has been written in the form of whole square, so that's why I'm only converting it. Okay, so this could be written as sine square x dx is not required. We have already calculated it. Okay. Yeah, plus c plus c plus c. And if you're wondering that why I'm not writing this minus 1 by 4, so actually this is being absorbed into c. Okay. So this could be written as x plus of sine x whole square by 2 plus of c. Okay. Here's the answer. Next question. So let us get dive into the next question. Yeah, okay. So sine square x plus of cosine square x plus of tan square x plus of cot square x plus of yeah, cosecant square x plus of secant square x dot dx. So sine square x and cosine square x could be written as 1, and tan square x could be written as secant square x minus of 1. So this will get added up, and yeah, and this could be written as cosecant square x minus of 1. So this and this will get added up. So finally we are left with 1. Okay, plus of 2 secant square x plus of 2 cosecant square x minus of 2 dot dx. Okay, yeah, so this could be written as 2 tan x minus of cot x minus of x plus of c. Done. So yeah, this is the answer. So let us move on forward. So yeah, next question. I believe this is the best question ever in this whole set of questions. Okay, so this is written as 2023 sine of x, the greatest integer. Okay, look, to evaluate this question, we need to observe the graph. Okay, I'll use graph, and let us look towards a sample graph of y is equal to floor of, let us say, 2 sine x. This would be much smaller, and as we know that the this function is very much symmetric. Both of these are very much symmetric to each other, so both of these will follow. I mean, I don't mean that they are symmetric, but actually they will pose the same behavior. Okay, so what would happen is that if I'll evaluate the floor 2 sine x graph, in that case I'll be getting the approximate, not even approximate, the actual way of the behavior of the floor of sine of 2023x, 2023 sine of x, and as we will run from 0 to 2023. Okay, so yeah, so yeah, let us construct the graph. So 2 sine of x. Okay, so this is the peak value which is to be written as 2, and the lowest peak value is to be written as minus 2. So yeah, okay, from 0 to 2 pi. Its periodicity is not affected since it's still now sin x. Periodicity or the period is determined by 2 pi over the coefficient of x. Okay, and in this case this is 1. So the periodicity is again 2 pi. So from here, one thing that I can conclude is that I'll need to plot out the graph of floor sin x. Okay, so first thing that I would like to conclude is that till there this would be sine inverse of 1, and at sine inverse of 1, sine of sine inverse of 1, it would be spitting out the value as 1. So till then the floor will be taking the least value, that would be 0. Okay, then after that it would be taking the upper values, and for some instance it will go towards 0, but as we know that it doesn't matter because this straight piece of line would not generate any kind of area. So yeah, and after that this will be sine inverse of 1. Okay, now and this would be pi minus of sine inverse of 1, right? This, and similarly this would be pi plus of sine inverse of 1, and this would be, and yeah, this would be like this, and this would be generating the output as -1. And yeah, this would be 2 pi minus of sine inverse of 1. Okay, okay. So if I'll see the area, then this would be the area under the graph, right? And yeah, in this case, the area would be this one, right? So for y is equivalent to floor of sine 2 sine of x, I'm plotting out the graph. Okay, so in this case, I'm getting the area to be written as, if I'll evaluate the area, then this would be pi minus of 2 sine, wait, this is too bold. Yeah, so pi minus of 2 sine inverse of 1 multiplied by 1. Okay, pi minus of 2 sine inverse of 1 multiplied by 1. Okay, minus of the lower area. First I'll evaluate this one. So this area is basically pi multiplied by 1. Right, pi multiplied by 1. This whole bunch is actually pi, and this whole length is 1. I mean the breadth is 1, and for this area this is 2 pi. Okay, pi minus of 2 sine inverse of 1. So minus of 2 into pi minus of 2 sine inverse of 1. Okay, all right. So this should be 1. Why? Because this length is 1. So length into breadth, that would be the area. So in this case, we are getting the answer to be as negative pi. So for y is equal to, look, the main thing that is to be observed here is that for y is equivalent to sine 2 sine x, we are getting the area as equivalent to pi. Now, for each and every part, as I can see that this whole bunch of thing will get cancelled and we are left with pi again. So by using or observing the same behavior, we can conclude that from 0 to 2 pi, the floor of 2023 sine of x dx is equivalent to minus of pi. So yeah, finally this is the answer. So let us move on forward. So let us move on forward. So the next question is from 0 to 2 pi to ln x plus of 1 e to the power log x whole square dot dx. Sorry, this is an indefinite integral, right? So this is an indefinite integral. All right. So let us evaluate it. So this could be written as 2 ln x e to the power of log of x whole square plus of, look, there are two methods to solve it. Let us discuss how to do it. Although they are correlated or they are exactly same, but okay, I'll do it. So if I'll use integration by parts in this case, look, the thing that I'll be using is nothing else but laws of cancellation. Okay, I will only operate a single integral on one side, and at last this will get cancelled out. Okay, so which one I should operate? This is the first thing that's coming in my mind. Okay, let us operate this one. Okay, I'm naming this as the next integral. Okay, so I'm taking 1 multiplied by 1 as v and this as u, and I'll use IBP, integration by parts again. So that is uv dx is equivalent to integral of u integral of v dx minus of integral of du over of dx integration of v dx. Right. So this could be written as 2 ln x e to the power of log of x whole square dot dx plus of, now I'm applying integration by parts, so I'm getting, yeah, x ln e to the power of ln x whole square plus of sorry, yeah, minus of integration of x to ln x multiplied by 1 by x e to the power of log of x whole square dot dx. This and this got cancelled, and exactly this, these both are exactly the same integral, so they are getting cancelled, so we are left with x e to the power of log of x whole square plus of c. So this is our answer. Or else, look, we can also do it directly using observation. How we can do it using observation? Let us look at it. So there's a direct method also, direct, and it depends that whether it's striking you or not. Okay, so the direct method is like integration of 2 log x plus of 1 e to the power log of x whole square dot dx. Now, if I'll see, then this could be written as 2 log x. This is something looking like the derivative of e to the power of log of x whole square. So, the thing that is missing is 1 over of x. Okay, so if I'm writing, I'll write here x also to fulfill the question. Now, plus of the derivative of dx of x e to the power of log of x whole square dot dx. Okay, so from here I can conclude that this could be written as yeah, so this could be written as e to the power of log x whole square. Okay, yeah, so this could be written as yeah, x e to the power of log x whole square. Because if I'll see, then this is u v prime v, right? And where's u? U is here. Okay, it's the derivative. It's just like uv prime plus of v prime u e to the power of x form. Okay, what I'm doing here is that e to the power of fx multiplied by f prime of x plus of fx dot dx is written as e to the power of fx x plus of c. This is the thing that is striking in my mind, and I'm getting the answer from here. Okay, so basically there are two methods to evaluate this question. Next question. So yeah, so the next question number 10 is basically, I believe this is the most easiest one. There's not need even to write it down. Okay, then also I'll write it. So 1 minus of x minus of x square whole to the power of 3 plus of x square minus of 1 whole to the power of 3 minus of 3 multiplied by 1 minus of x minus of x square multiplied by x square minus of 1 dot dx. So instantly what's striking in my mind is that this is written as the form of a b c minus 3a b c. Again, a cube plus b cube plus c cube minus of 3abc. It's written in the form of 3abc. Now the thing is that is to be observed is that this could be written as a plus b plus c multiplied by a square, or else directly this could be written as summation of ai multiplied by summation of ai square minus of summation of ai bi. Okay, now in case if a plus b plus c is equivalent to 0, then in this case aq plus bq minus of 3abc is equivalent to 0, and if I'll see, then 1 minus of x, okay, 1 minus of x plus of x minus of x square plus of x square minus of 1, this all got cancelled, so a plus b plus c is equivalent to 0, so this integral is actually equivalent to 0 dot dx, and the answer is 0. Done. It's just observation. Next question. Next question is also very much interesting. So what MIT has given in this question is minus of 2023 to 2023 mod of x minus of 1, again mod of x minus of 1, again mod x minus of 1, again mod x minus of 1, minus of and up till mod x dot dx, and they have told that there are 2023 negative 1. First of all, there's not any need for even an odd function in this case, as I can see that it's already odd. So it might become more tough in case if you will apply the property of odd function, that is from minus a to a fx dx, and if fx is equivalent to odd, then this could be written as 0 to a fx dx, right? So I'll not prefer to use this property since as I can see that we should plot out the graph. Okay, so let us just start with y is equal to mod x graph. So when I'll plot the graph of y is equal to mod x, in that case the graph is like this, right? Right, symmetric. Y is equal to mod x, and notice that this is 45 degrees and this is 45 or pi by 4. Okay, anything. Now, in case if I'll plot out the graph of y is equal to mod x minus of 1, again mod. So let us see that how will the graph look. So the function will get shift down by negative 1, and the mod will go there upside. Okay, yeah, so this would be the graph, and this would be y is equal to mod of mod x minus of 1. You can even plot in Desmos. Okay, so if I'll plot out in the Desmos graphing calculator, let us see it. Okay, let us plot it by your hands only. Okay, so yeah, again, when I'll draw the graph of mod x minus of 1, shifting the function down by 1 and then again taking the mod. So let us do it. So yeah, so the function will go down by 1 and this function will look like this, and then we will take the mod of this graph. Okay, so this will look like something this. Yeah, like this. And let us again take the mod of mod x minus of 1 minus of 1 mod minus of, and then again taking shifting it down by minus 1 and then again taking the mod. So if I'll see, then the graph will look something like this. This will go down by this. Okay, so this is something like, okay, so this has been shifted down by minus 1 units, and this will become like this. Yeah, so we will erase the lower one. All right, so the thing that is to be observed in this case is that, as I can see there, that basically this graph was shifted by 1 minus 1. All right, so then this will become 1 and minus 1, and this will become like 1 minus 1 minus 2 minus 3 1 2 3, right? And since the function has been always shifted up and down by 1 only, so this length is not affected. In this case also this was 0 comma 1, this height was 1, and in this case also the graph was 1. Okay, and in this case also the height is 1. Now the thing that is to be observed is that in this case, till the time we have taken 3 times negative 1, Okay, that is being included in our modulus function. So in this case, as I can see that there are three rectangles that are have been formed, right? So imagine if we are doing 2023 minus 1. In case if we are doing 2023 minus 1, then there will be 2023 triangles, 2023 triangles, right? Okay, now one triangle has area. The area of one triangle is equivalent to, if I'll see, then this is equivalent to half base is 2, right, multiplied by height, this is 1. So if one triangle will be of area 1, then 2023 triangles would be of area 2023 multiplied by 1. So the answer is 2023, right? So yeah, this is our answer. So the answer to this question is 2023. So yeah, this was exactly an excellent question, and it was very much interesting to evaluate it. So let us move on to the next question. So the next question is integral sine to the power 6x. Again, a manipulative question. Cos to the power 6x plus of 3 sine square x cosine square x dot dx. And yeah, this is question number 12. So this could be written as, if I'll observe, then this is the form of a cube plus of b cube, and a cube plus of b cube is equivalent to a plus of b multiplied by a square plus of b square minus of ab, right? So this could be written as sine to the power 2 whole to the power 3, that is sine that is sine to the power 6x plus of cosine to the power 6x plus of 3 sine to the power 2x cos to the power 2x dot dx, right? So this could be written as sine square x plus of cosine square x, that is equivalent to 1, and sine to the power 4x plus of cos to the power 4x minus of sine square x cosine square x plus of 3 sine square x cosine square x dot dx. So from here I am getting sine to the power 4x plus of cos to the power 4x plus of 2 sine to the power 4x cos to the power 4x dot dx, sorry, 2x, right? So this could be written as sine square x plus of cos square x whole square dot dx, and the answer is 1, since sine square x plus of cosine square x is equivalent to 1. So this is the integral dx, so the answer is x plus of c. So here's the answer. Next question. So the next question is integral x plus of e plus of 1 whole to the power. Okay, so the next question is x plus of e plus of 1 whole to the power x to the x to the power of e to the power of x dot dx. Now, how can I evaluate this integral? So let us do some observation that how I can do it. So in case if I'll take x to the power e as 1, will it help me? Will it help me? Will it help me? I don't think that it would help us. So e to the power of x. Okay, let us do one thing. Let us do it x plus e plus 1, and let us write it down as ln e to the power of ln x to the power of e. Okay, e to the power of x, since e to the power of ln b could be written as b. Actually, in reality there is e also, so that is why the base will get cancelled out and the answer is b. Okay, so using this property, what I'm doing is that I'm writing it down as x plus e integral x plus of e plus of 1 e to the power ln of x to the power of e plus of 1, or else e plus of x dot dx, right? Okay, so from there, if I'll see, then this could be written as x plus e to the power of e ln x plus of x e to the power of ln x. Okay, plus of integral of e to the power of e ln x plus of x dot dx. Right, so I'll take 1 as v. Okay, so from there I'm getting x e to the power of e ln x plus of x minus of integral. I'm applying integration by parts. Okay, so I'm taking this as v. So from there I'm getting x, um yeah, x, and then the derivative, that is e over of x plus of 1 e to the power of e ln x plus of x dot dx. Right, so x will go there and x and x will get cancelled. So as I can see there, I'm getting some hope of the integration to get cancelled out. Okay, yeah, so by the laws of cancellation, this and this integral will get cancelled out, so we are left with x e to the power of e ln x plus of x plus of c. Okay, yeah, next question. Okay, in the answer key, the answer could be also written as x, okay, x multiplied by x to the power of e plus of e to the power of x. So this could be written as e to the power of x. This is not plus, but this is multiplied, so e to the power of x multiplied by x to the power of e plus of 1. Okay, plus of c. Yeah, so this could be also written. Okay, now let us move on forward. So the next question is to evaluate the integral from 0 to 1 x square over of 2 minus of x square plus of under the root of 2x divided by x plus of 1 dot dx. So let us evaluate this integral. Okay, so this could be written as minus of, okay, minus of 2 minus of x square plus of minus of 2 divided by 2 minus of x square plus of, okay, yeah, dot of dx plus of 0 to 1 root 2 root x over of root x plus of 1 dot dx. So from there I'm getting this to be 0 to 1 minus of 1 plus of 2. Okay, I'm writing the minus here. So 2 minus of x square dot dx, this could be written as root 2 whole square dot dx, and plus of root 2 from 0 to 1, and x divided by under the root of x square plus of x dot dx. So this is x 2 2 plus of 1 minus of 1. I'm doing it like this because the derivative of this x square plus x is basically 2x plus 1. So I'm doing it such that I can use the substitution. So after evaluating this integral, this would be minus of x plus of 2 divided by 2 root 2 ln mod of root 2 plus of x divided by root 2 minus of x from 0 to 1, and limit from 0 to 1. This is how much x, okay, so plus of 1 over of root 2 0 to 1, 2x plus of 1 over of under the root of x square plus of x minus of 1 over of under the root of x, okay, minus of half. Now I am forming the whole square. Okay, x plus of half whole square. Let me see the so this could be written minus of 1 by 2 whole square. Yeah, so this is minus of 1 by 2 whole square. Hope that I am going correct. I hope that I'm going correct. Let me see it. Yeah, okay, I'm going right. So minus of 1 plus of 2. Okay, 2 and 2 got cancel. 1 by root 2 ln mod of root 2 plus of 1 over of root 2 minus of 1 and 0 0, and this will be ln mod of root 2 over root 2, that is ln mod of 1, and then that is equivalent to 0. And in case if you're wondering that how I directly evaluated there, so the reason is that there's a formula that is 1 over of a square minus of x square dot dx is equivalent to 1 over of 2a ln mod of a plus of x over of under the root of I mean ln mod of a plus of x divided by a minus of x plus of c. Okay, so yeah, by using this formula I have evaluated the integral directly there, and here I'll take x square plus x as t. So from there I'll get it as 1 by root 2 multiplied by 2 under the root of x square plus x. Why? Because integral of 1 by of u 1 by root 2 du is equivalent to 2 root of du plus of c. So in this case, this could be written as minus of 1 plus of 1 by root 2 ln mod of root 2 plus of 1 divided by of root 2 minus of 1 plus of 1 by of root 2 integral from 0 to 1, and this could be written as okay, why I'm writing the integral, this has been already evaluated. Okay, so that is 2 under the root of x square plus of x limits from 0 to 1 minus of the integral which is left, that is 1 by root 2 integral from 0 to 1 1 over of under the root of x plus of half whole square minus of 1 by of 2 whole square dot dx. And yeah, this could be written as by the standard formula of integral of under the root of x square minus of a square dot dx could be written as under ln mod of x plus minus of plus of x square minus of a square plus of c. So by okay, let me write it down clearly. So the formula that I'm using there is integral of 1 over of x square minus of a square dot dx, and this could be written as ln mod of x plus of under the root of x square minus of a square plus of c. Okay, so yeah, after applying this formula, I'm getting there uh, uh, ln mod of x plus of half integral of under the root of x plus of half whole square and minus of 1, that is equivalent to x square plus of x plus of c. And after putting down the limits, I'm getting there root 2 that is equivalent to root 2, so this could be written as plus of 2. Okay, and yeah, in this case also I'll not write the c because there's an indefinite integral, so limits from 0 to 1. So this could be written as minus of 1 plus of 1 over of root 2 ln mod of. Okay, ln mod of, when I'll rationalize it, I'll be getting 3 plus of 2 root 2, right? Ln mod of 3 plus of 2 root 2. So yeah, in this case I'm getting there 1 plus of 1 over of root 2 ln mod of 3 plus of 2 root 2 plus of 2 minus of half ln mod of x plus of half x square plus of x. Okay, let me put the limits directly. Okay, so this could be written as ln mod of 3 by 2 plus of root 2, right, minus of half ln mod of plus, I mean yeah, plus ln mod of 0 0, and this will become half, right, ln mod of half, right. Okay, yeah, so this is root 2. So yeah, so let us continue. So this could be written as 2 root 2. This will go upside, so this could be written as 2 root 2, right? So this could be written as 1 plus of 1 by root 2 ln mod of 3 plus of 2 root 2. Okay, minus of 1 by root 2 ln mod of 3 plus of 2 root 2 by uh, okay. So this was plus. So this will be minus of half ln mod, and this 2 will come here and minus plus, right? Yeah, so plus of half ln mod of half, right, plus of half ln mod of 1 by 2. So this and this will get cancelled, and this will get cancelled, so finally we are left with 1. So the answer is 1. So to this integral the answer is 1. So let us move on forward. So yeah, the next question is, basically the next question is an indefinite integral of 2x to the power of 2022 divided by 1 x plus of x to the power 2023. Looks like I'm getting some kind of substitution there. Okay, so yeah, this could be written. So okay, so I'm making the kind of substitution that could be directly integrated. Okay, so 1, the derivative of x is 1, and 2023 x to the power 2022 minus of 2021. Now I'm balancing it, so x to the power of 2022 x plus x whole to the power 2023 dot dx, x plus x 2023 dot dx. Okay, so integral of ln mod of x plus of x square x to the power of 2023 minus of if I'll see, then x is getting cancelled from there, so this will become 2021 x to the power of 2021 divided by 1 plus of x to the power of 2022 dot dx. And if I'll take this as t, okay, I've taken this as u, and then I have cancelled the upper part. Okay, and of course this is becoming integral of 1 over of u du, and this could be written as 2021 x to the power 2021 divided by t dt by 2022 x to the power of 2021. So this will get cancelled. So ln mod of x plus of x to the power of 2023 mod closed. So from there, this could be written as ln mod of x plus of x to the power of 2023 minus of 2021 by 2022 ln mod of t, and t is equivalent to 1 plus of x to the power of 2022 plus of c, right? So yeah, from there this could be written as ln x plus of ln of 1 plus of x to the power of 2022 minus of 2021 divided by 2022 ln mod of 1 plus of x whole to the power of 2022 plus of c. So from there, ln mod of x plus of ln mod of 1 plus of x to the power of 2022 divided by 2022 plus of c. Right. So, okay, in order to make it down to be equal to the answer which is given there, look, what I'm trying to do is that I'm trying to make the answer exactly equal that is given there in the answer here, although this is also correct. Okay, this answer is also acceptable, but let us make it down like this. Okay, so I'll multiply 2022 2022, and this will go to the exponent. So this will become x to the power 2022 plus of x to the power 4044, okay, divided by 2022 plus of c. So yeah, this is the answer. So let us move on forward. Next is question number 16. So it's asking that to evaluate the integral of 3 sine of 20x cos of 23x, okay, plus of 20 sine of 43x, and here dot dx. As simple, I'll apply sine of alpha to sine alpha cos beta is equivalent to sine of alpha plus beta plus of sine of alpha minus of beta. So this could be written as 3 by 2 sine of 20x cos of 23x plus of 20, okay, yeah, this one is dx, plus of 20 sine of 43x dot dx. Okay, so 3 by 2, and this could be written as sine of a plus b, that is 43x minus of sine of y minus, because sine of 23 minus of sorry, I mean sine of 20 minus of 23 is basically minus of sine 3x, right? Sine 3x dot dx, and plus of 20 sine of 43x dot dx, right? And okay, and in case if I'll evaluate the integral, then I'll be getting integral 3 by 2 minus of cos of 43x divided by 43 plus of 1 by 3. Okay. One thing that I can do it to make the calculation even more faster is that I can directly see sine 43 and sine 43. So this will become 43 by 2 sine of 43x, okay, minus of 3 by of 2 sine of 3x dot dx, and I'll evaluate the integral. So this will become 1 by 2 cos of 43x dot dx plus of, okay, yeah, minus of 1 by 3, okay, so plus of 1 by 2 cos of 3x dot dx. So this will become uh yeah, cos of 43x minus of, okay, so this could be written as half cos of 3x minus of cos of 43x. Now, plus of c. We can do even more. We can even more simplify it. That is, this could be written as cos of 3x. Okay, so cos a minus of cos b. As we know that cos a minus of cos b is equivalent to 2 sine of a plus b by 2 minus, okay, sine of a minus of b by 2. So this could be written as minus of 2, okay, minus of 1 multiplied by 2 sine of a plus b 43, yeah, 46, that is 23, 46 by 2, that is 23x sine of 40, sine of 20x divided by 2. So this and this will get cancelled. So minus will also get cancelled since there was a minus there. So this will become sine of 23x sine of 20x plus c. So yeah, here's the answer, 20x. Yeah. Next question. Next question is to evaluate the integral from 0 to 1, the continued product of k is equal to 0 to infinity 1 by x plus of x to the power of 2 whole to the power of k dot dx is equivalent to half. We need to prove it. Okay, so we need to prove it. So this is basically question number 17. So how I can do it? The first question that strikes in the mind that is that, okay, I hope that we all know that what is this symbol means. This is the symbol of continued product. Okay, that means if I'll open this integral, then this will become integral 0, yeah, also, okay, so integral 0 to 1, uh, k is equal to 0 to, okay, I'm opening it, so this will become 1 by x plus of 1 multiplied by 1 plus of x square, okay, again multiplied by 1 plus of x to the power of 4, 1 plus of x to the power of 8, okay, plus up till infinite 1 plus of x to the power of infinite dot dx. Now I'm gonna doing one manipulation since this is a very familiar series. That one thing that I know already is that whenever you get such series like this, 1 plus of x square, 1 plus of x to the power of 4, 1 plus of x to the power of 8, and up till so on, do only one thing. Do only one manipulation. Multiply and divide by x minus of 1. X minus of 1. And now, as always, magic will happen. Okay. Okay, let me write it as 1 minus of x. So 1 plus of x, I am dividing it by 1 plus of x, 1 plus of x. So this will become 1 minus of x square, 1 plus of x square, 1 plus of x to the power of 4, 1 plus of x to the power of 8, infinite divided by 1 minus of x. Okay, so 1 minus of x to the power of 4, 1 plus of x to the power of 4, plus of up till infinite 1 minus of x, and yeah, this could be written as 1 minus of x to the power of 8 over of 1 minus of x, and so on. So this will go on like 1 minus of x to the power of infinity over 1 minus of x. So similarly in this question, what I'll do is that I'll multiply and divide by 1 minus of x. So if I'll multiply and divide by 1 minus of x, this will become 1 minus of x square, 1 plus of x square, 1 minus of x to the power of, 1 plus of x to the power of 4, 1 plus of x to the power of 8, 1 plus of x to the power of 16, 1 plus of x to the power of 32, and so on dot dx. Okay, so this could be written as 1 divided, 1 minus of x divided by 1. Okay, 1 minus of x to the power infinity, since it's tending to infinity. And the main thing that is to be noticed is that x is running from the limit 0 to 1. Right, so x is in between 0 to 1, so x belongs from 0 to 1, so this will go till 0. Okay, x to the power of infinity will become 0, so this will be from 0 to 1, 1 minus of x dot dx, so this could be written as x minus of x square by 2 from limit from 0 to 1, so this could be written as 1 minus of half, which is written as half. So the answer is half. And you may also do it by the general series, or there's one more method to evaluate it. This was the most quickest method, and this was through a small manipulation. Just multiply and divide x minus of 1, x minus of 1, or 1 minus of x, both the sides on the upper side in the numerator and denominator. There's one more method, that is you can write it down as 1 minus of, okay, so this is a kind of an observation method. If you'll see, then x plus of 1 into x squared plus of 1, if I'll multiply both these terms, then this will become x plus of x squared plus of x cube plus of 1. Right, and then again when we will multiply it by x cube plus of 1, then this will become x1 plus of x square plus of x cube plus of x cube. Okay, uh, yeah, plus of x to the power of 4 plus of x to the power of 5, and up till like this, and this will become a geometric sequence. And for the sum of geometric sequence, we know that the sum is the first term into 1 minus of common difference whole to the power of infinity over 1 minus of x dot dx. Okay, so yeah, this could be written as integral from 0 to 1, 1 minus of x dot dx, since x is running from 0 to 1. So this could be written as x minus of x square by 2, limit from 0 to 1. So this could be written as 1 minus of 1 by of half. So the answer is half. Next question. Let us see the next question. Detail. So next question. Yeah, all right. So we need to evaluate the indefinite integral of sine x over of 2 e to the power of x. Okay. 2 e to the power of x plus of cos x plus of sine x dot dx. Okay. So what I'll do is that I'll consider sine x as equivalent to lambda multiplied by 2 e to the power of x cos x plus of sin x, and this is the general method that we follow, multiplied by mu of the derivative, that is 2 e to the power of x minus of cosine x plus of minus of sin x. Okay, so the derivative of sin x is cosine x is minus of sin x plus of cosine x plus of k. Okay, and from here if I'll compare, then 2 lambda, okay, plus of 2 mu is should be equivalent to 0. This is equation 1 that I'm getting, and yeah, k should be equivalent to 0, and this is equation 2. And finally for sin x, okay, there are two more equations, that is for cosine x, that is uh, lambda, okay, plus of mu should be equivalent to 0, and for sin x 1 should be equivalent to lambda minus of mu. 2 lambda should be equivalent to 1, lambda should be equivalent to half. So lambda is half and mu is equivalent to minus half. Right, lambda is half and mu is equivalent to minus half. So when I'll put this down in the equation and I'll transform the numerator, then I'll be getting, okay, so after transforming the numerator, I'm getting half. Okay, I'm putting the value of lambda, so that is 2 e to the power of x plus of cosine x plus of sin x divided by 2 e to the power of x plus of cosine x plus of sin x dot dx minus of half. Okay, I'm again putting the value of minus of half, that is 2 e to the power of x, the derivative minus of sin x plus of cosine x divided by 2 e to the power of x plus of cos x plus of sin x dot dx plus of k is equivalent to 0. So after evaluating this integral I, okay, this was also I. I'm just writing it down. Okay. Although there's not any sense to write it down in this problem. Okay. So yeah, so this could be written as this will get cancelled. So x by 2 minus of this is u and this is u prime. So this could be written as half ln mod of 2 e to the power of x plus of cosine x plus of sine x plus of c. So this could be written as half x minus of ln mod of 2 e to the power of x plus of cos x plus of sine x plus of c. So this is our answer to question number. This was, yeah, so this was question number 18. So this was our answer to question number 18. So let us move on forward to question number 19. So yeah, next question is question number 19. So it's told to evaluate the definite integral of x over of pi divided, okay, log of x over of pi divided by log of x whole to the power log pi e dot dx. So I can write it down as log of x minus of log of pi divided by log x, and this could be written as log pi plus of log e base e, that is 1. So log pi plus of 1. So this could be written as log x minus of log pi divided by log x whole to the power log pi log x. Right. So when I'll divide it, okay, there should be dx. So this is to be written as 1 by log uh, log x whole to the power log pi, okay, minus of yeah, minus of the integral of log pi and log x whole to the power minus of ln pi plus of 1 dot dx. So log x whole to the power log x whole to the power minus of ln pi dot dx. So I'll use the laws of cancellation. Okay, yes, the laws of cancellation. So using the laws of cancellation, I can write this one as okay, I'll apply IBP, integration by parts, on this. Okay, so this would be written okay, so I'll take one as v and this as u. So x ln x whole to the power minus ln pi, okay, plus of integral of x, okay, ln pi log x whole to the power minus of ln pi plus of 1 over of x, and x this got cancelled, so minus of log pi integral of log x whole to the power, okay, yeah, so whole to the power minus of ln pi plus of 1 dot dx, plus of 1 dot dx. Right, so yeah, both of these terms will get cancelled, so we are left with this final term, which is x ln x whole to the power of minus pi minus ln pi. So the final answer is x over of ln x whole to the power ln pi. This is our final answer. Okay, yeah, so finally let us move on to the to our final answer. Okay, sorry, I mean to the final question. Okay, so this answer is right or wrong? I don't know about it. Okay, let me check it. Yeah, it's correct. Okay, yeah. So x divided by ln x. So basically what I've done is that I've applied integration by parts on this, and as you can see that there's a term generated which is exactly generated to cancel out the next term. So we are getting the answer to be x ln x, yeah, whatever, x divided by ln x whole to the power of ln pi. Let us move on forward. Let us move on forward. So our last question is let me check it. Yeah. So our last question is to evaluate the integral from minus 3 by 2 to minus of half. Okay, and x to the power of 5 plus of 5 x to the power of 4 plus of 10 x to the power of 3. Okay, plus of 8 x square plus of x dot dx. We need to evaluate it. Look, to evaluate this question, one thing is clear that if I'll evaluate it directly by using integration of x to the power of n dot dx is equivalent to x to the power of n plus of 1 divided by n plus of 1 and then putting down the limits from x1 to x2, this would be devastating. This would be very much dangerous. You will get flown out. So, what you can do there? Let us apply some logic or some kind of thing. This what we are seeing right there, that is x to the power of 5 plus of 5x to the power of 4 plus of 10x to the power of 3 is actually the expansion of x plus of 1 whole to the power of 5. How? If I'll expand x plus of 1 whole to the power of 5 using binomial expansion, then okay, or else by anything, you will be getting x to the power of 5 plus of 5x to the power of 4 plus of 10x to the power of 3 plus of 10x square plus of 5x plus of 1. Okay, so this is the expansion of x to the power of 5. Okay, so this is the expansion of x to the power of 5. So one thing is sure that there is something for x to the power of 5. So minus of 3 by 2 to minus of half. If I'll write it down as x to the power of 5 plus of 5x to the power of 4 plus of 10x to the power of 3 plus of 10x to the power of 2 plus of 5x plus of 1. And now to balance out the whole question, this, this, and this is exactly taken from there. And to make it as 8x square, I'll subtract minus of 2x square. And to make it as x, I'll subtract minus of 4x and minus of 1. Right, dot dx. Okay, so this could be written as minus of 3 by 2 to minus of half. Okay, so that is x plus of 1 whole to the power. So this could be written as x plus of 1 whole to the power of 5. Okay, x plus of 1 whole to the power of 5 minus of uh, uh, 2x square. I'll take 2 as common because I'm seeing that there's something like a perfect square, so I'll write it as minus of 2 plus of 1. Okay, minus of 2 plus of 1, so 2x square minus of okay, plus of 2x plus of 1. Okay, plus of 1 dot dx. So from here I can see that this could be written as I is equivalent to minus of 3 by 2 to minus of half x plus of 1 whole to the power 5 minus of 2 x plus of 1 whole square plus of 1 dot dx. Now this could be directly evaluated as minus of half minus of plus of 3 by 2, that is 1. Okay, so minus of 3 by 2 1 plus of minus of half x plus of 1 whole to the power of 5 minus of 2 x plus of 1 whole square dot dx. So in this case I'll use the shifting property in order to evaluate the integral. So that is, the shifting property says that if you are evaluating an integral from alpha to beta fx dx, and if you are shifting the function by alpha, in that case okay, not by alpha but by k, then this could be written as the integral from alpha. Okay, if I am shifting the integral by plus k, then f of x plus k, then this will, then in the limits minus of k will get subtracted. Okay, and this is known as the shifting property. Shifting property. Okay, yeah, so by using the shifting property, this is actually the case of substitution only. Okay, but or else you can either take x plus 1 as equivalent to t. Okay, so I am using the shifting property. So from there, minus of 3 by 2 plus of 1, which is equivalent to minus of 3 by 2 plus of 1 minus of half plus of 1 and x minus of 1. I am subtracting minus 1, so the limits will get plus 1. Okay, it's just the opposite. So minus of 2 x square dot dx plus of 1. So minus of half से लेके half x to the power of 4 minus of 2x square dot dx plus of 1. So this could be written as 0, and as this is an even function, so as this is an even function, 2x square from okay, multiplied by 2 again from 0 to half dot dx. So this could be written as minus of 4 by 3 x cube from 0 to half plus of 1. Right. So finally, this could be written down as minus of 1 by 6. Okay. Minus of 1 by 6 plus of 1, that could be written as 5 by 6 plus of, okay, why I'm writing C. Yeah. So the answer is 5 by 6. So this is all, and we are now completed with the MIT Integration B solutions, and hope you enjoyed it. Okay, yeah. So, yeah, this was all about the integration B. So, thanks. And this was the qualifying exam answers.